it might be worth talking about is how we could write this without using a regular expression. It's an interesting and kind of fun thing to work on, although fairly impractical. I think that it makes far more sense to understand and use regular expressions, but still challenge yourself. How would you do this without the regular expressions? So my first idea was that I would lowercase the word here. That's what I'm doing on the first line, because that's just part of the specs here is that we're only going to deal with lowercase words. And then the I want to find for A, E, I, O, U if they occur in the word. So let's start up a REPL here, and let's say the word is equal to apple. And I want to find all of the positions of the vowels in this word. So I'm going to have to force this to a list here to use this. But what it's showing me is that the letter A occurs at the position 0. The letter E occurs at the position 4, which is at the end of the word. And then I has the position -1, which is what I'm using here to show that the character does not appear in in the word. I cannot use 0 because 0 is a legitimate index position. So I want the index of the character if the character is in the word. I have to say if C in word because if word index, so if I say word index of X, that's going to throw an exception. So I need to first check if the character is in the word. So this creates this thing called what I call here vowel map. Um, Let me say vowel map here, and I can verify what it looks like. So that's this list I have here. Now what I want is the position, well here I'm sorry, I want to get all the positions um, that actually exist. So what I'm doing here is I'm using a filter, which we saw before. I want all the values that are greater than or equal to 0. And I say, what is position? And now that just gives me 0 and 4. Another way I could have written that would be, let's see, I could say P for P in vowel map if P is greater than or equal to 0. That's another way to write that. I need an equal sign. And I can say what is P, and it gives me exactly the same answer. So this is a list comprehension with a guard, and this is writing it as a filter. So given those positions, the first one is going to be the min. I can say what is the min of position, and it's going to give me the first position. Just making sure, because here in this particular instance, A was first, and it happened to be the first one in the vowel in the word. But that doesn't necessarily have to be the case. So I want the minimum position. So the first is going to be equal to the minimum from the position. And then I can say, what is word up to the first character? And it will be the empty string. And what is word from the first character on? And it will be apple. Let's change word to something else like chair. And then go back and let's create a vowel map here. And then we can say create our position. And let's look at those same ideas here. What is, see, first is going to be equal to the minimum of position. Well, first let's look at vowel map. That is, this was showing that the character A occurs at position 2. The character E does not occur. The character I occurs at position 3. O and U are both not found. So therefore, the positions of the vowels are in indexes 2 and 3. So the first is equal to the minimum of those positions if that's going to be equal to 2. So I can say what is word up into the first vowel. It's going to be chair, the CH. And then what is it from that first position on? It's going to be AIR. And so that is how I could create this the same return from the stemmer function without using regular expressions. If there's no positions, for instance, if the word is equal to redunzel, and I can say what is the vowel map for that, that's going to be all -1s. And so there will be nothing for position. There will be no first position that we could choose. Anyway, so that's a way to write this without using regular expressions. I hope that you see the benefit of using regular expressions, because then we get to just simply declare what we're looking for, and we let the regular expression engine figure out how to make that work. So in this, to wrap up, the thing about what I really like about regular expressions is that it's a declarative approach to programming rather than imperatively us figuring out how to write code that manually finds these patterns. It's much, much easier if you start to learn to incorporate regular expressions instead of trying to write brute force code like this, even though I have to admit the brute force code is kind of fun to write. Um, we can capture parts of regular expressions by putting parentheses around them. And when we use either the re-match, the re-search functions, we can then call if we have a match, then we can call the groups to find what those substrings are that we found. Um, we can add a guard to a literal list comprehension to avoid taking some of the elements, and that is the same thing as writing a filter. They both will produce new lists where the elements meet some criteria. We also talked a little bit about how many Python types from strings, numbers, lists, and dictionaries can be evaluated in a Boolean context to arrive at this something that is truthy or falsy. You don't have to use just true and false. For better or worse, it can actually get you into a lot of trouble if you don't explicitly understand what you're doing. But things like the empty string, the integer 0, the floating point value 0, the empty list, and the empty dictionary are all considered falsy. And so any of those types that are not empty, like the non-empty string or non-empty list or dictionary, those are truthy. So you can use that in your coding, but just be very careful you understand what you're doing. Lastly, we've also talked about, well, maybe not quite lastly, but we've talked several times about different ways of breaking up long lines of string literals that you want to include in your program. In the insult generator, we looked at using the triple quoted strings to put in a big block of text into your program to make that more readable. And here we broke up long string literals onto several lines, and we made sure not to put commas after them. And then with parentheses around them, Python just put those all together. And if we, with the parentheses and commas though, it would have made a tuple. So that's another way of breaking string literals over multiple lines, and Python will implicitly concatenate them together. Lastly, the most important thing I hope you took from this exercise is trying to figure out how to write small functions and then tests for your code, and then understanding that you can share your code from other modules. You can, every time you write a function in a program, you can actually move that function into a module and then import it into other programs. So this is a way of sharing code between the programs that you write. And every one of those functions that you write that you want to share, you need to make sure that you're writing tests for them so that you understand what you're doing.